Lesson 2.1, the balance of a system of convergent forces from the book Mechanical Systems Calculations of the Marine Facilities. The important is the concept of the balance of the convergent forces. We assume that convergent forces are those lines of action that intersect at one point. They are shown in the diagram on the draft 2.1.1. So F1, F2, F3, etc. Fn vectors of the convergent forces. The lines of action of these vectors intersect in the definite one point. In this diagram, we coincide this point with the reference point of the Cartesian system of coordinate. X, Y, Z, 0, reference point and the point of the intersection of the lines of action of the convergent system of forces. The concept of the resultant of the convergent system of forces. We can use a parallelogram rule to find the resultant of the convergent system of forces. And we can do this consequently. So the resultant of the first couple of forces, F1 and F2, we can find by the parallelogram rule. This will be the resultant. We indicate 1, 2 of the forces F1 and F2. Next to this resultant, we can add the force F3. Force F3 here we have, and we have the resultant using the parallelogram rule R1, 2, 3 as a vector of the resultant of forces F1, F2, F3. We can do this, and finally we have the general resultant. This general resultant R vector asterisk is we can find as well just by consequent summarizing of the forces F1, F2, F3, etc. If we put the beginning of each of the force vector to the end of the previous one. So we can find consequently the resultant force as well. This is convergent forces. Difference with the usual balance equations of the balance of system of convergent forces is that for usual system of forces, we have usually three types of the balance equations. The first type is the equivalence of for the flat case, for example, for the flat case, for usual system of forces, equivalence of projection of force on the axis of the coordinate x and y have to be equal to 0. So this is two equations, and the third equation is the equivalence of the moment rotating around any point have to be equal to 0. And second, for the usual flat option of a balance of system of forces located on one plane, not for the convergent system of forces, I just remind, as usual for system of forces in the flat case. Another option of the balance equation of flat system of forces equivalence of the rotating moment of all efforts on the plane acting on the system, on the mechanical system, equivalence to 0. So we have three equations as well. And we can make a choice of arbitrary points of rotation, but they have not to be on the same straight line. And the third system of the balance equation for usual flat case of action of the efforts on the mechanical body is then two moments of the definites of any arbitrary points have to be equal to 0. And the projection of forces on any of the axes on this plane have to be equal to 0 if only this axis would not be perpendicular to the segment between the points of rotation considered in the previous two equations of the third case of the balance of system of forces. For system of the convergent forces, the difference is that we do not need to do the equivalence to 0 of the total of action moment of all efforts due to as the forces acting on the mechanical body intersect in one point, the rotation moment caused by the system of forces do not cause the rotating moment. So we have no rotating moments of the convergent forces relative to the reference point. So we can reduce the assumption of the balance of system of convergent forces just to equivalence to 0 of the resultant of the convergent forces. It can be equivalence of the resultant by the resultant algebraic magnitude. To find the algebraic magnitude of the resultant, we can find first the projection, so the resultant on two axes as is known as the projection of the resultant on x-axis equal to total projections of all forces converging on the x-axis. Projection of the resultant on y-axis is the same as the projection total of the projection of all forces projections on y-axis, and the projection of the resultant on applicate axis equal to total of the of all projections of forces on z-axis. After finding the projection of resultant on axis xyz, for example, Cartesian coordinate system, we next can find the magnitude of the resultant as square root of the sum of three summands each in the square degree. Summands are projections of the resultant on the axis x, y, z. So besides of finding the resultant, usually we have to find the cosine of the direction angles between the resultant and the abscissa axis, and between the resultant and the ordinate axis, and the resultant and the applicate axis. Just using the projections and using the found magnitude of the resultant. To have the system of convergent forces in balance, we have to find the equality of the resultant to 0. This is the balance equation. Conditional balance of convergent force system. For the balance of the convergent force system, it is necessary and sufficient that the magnitude of the resultant forces be equal to 0. That's why, because the convergent system of forces do not cause the appearance of the rotating moment, as all forces intersect in one point. Usually we can coincide it with the reference point of the Cartesian coordinate system. For the balance of special system of convergent forces in scalar form, it is necessary and sufficient that the totals of the projections of forces on each of the three axes of the rectangular Cartesian coordinate system be equal to 0. So to have equality to 0 of the resultant of the convergent system of forces, each of the projections have to be equal to 0. For the balance of a flat system of convergent forces in the analytical form, it is necessary and sufficient that the totals of the projections of forces on each of two axes of Cartesian coordinate system be equal to 0. So for flat system, this rule of the balance of the converging system of forces reduces to only two equations of the balance. Three-force theorem. If the system of three non-parallel forces lying on the same plane is in the balance, then the lines of action of these forces intersect at one point. Yes, how to explain this? For example, we have three forces, F1, F2, and F3. If these forces, this is in the balance, then we can consider two forces, F1 and F2 vectors in the flat state, and using the parallelogram rule, we can find the resultant of forces F1 and F2 as R12, this vector. To have the system, mechanical system in the balance, this force have to be balanced with the force F3. That's why it have to be on the line of action of force F3. This means that got from the intersect of forces F1 and F2 line of actions force resultant of these two considered forces at the same time lie on the line of action of force F3. That's why lines of action of these three forces intersect at one point, this point 0. Questions and comments. The reducing the system of converging forces to the resultant, the projection of resultant on the coordinate axis, the magnitude of resultant, the cosines of the direction of angles. To find the resultant of the convergent forces, we can consequently use the parallelogram rule, and for each, so for the first couple, arbitrarily choosing the couple of convergent forces, we can, using parallelogram rule, find the resultant of these two forces. Next, we can consider this got resultant as a new force, and using parallelogram rule, we can find the resultant with third force with the resultant of previous two. And we can do this consequently until the last force in the system of the convergent forces. It's one of the ways how to reduce the system of convergent forces to resultant. Another way is just to put the beginning of each force vector to the end of the previous one, and this sequence of vectors gives us the resultant from the geometrical point of view. The projection of the resultant on coordinate axis we can find as a total of projection of each of forces in the system on the coordinate axis, each of convergent forces. This, like usual, the magnitude of the resultant we can find using the Pythagoras theorem by the square root of the total of squares of projection of resultant on the coordinate axis of Cartesian coordinate system rectangular. The cosines of the direction of the angles of the resultant we can find as well as a proportion of each of projection of resultant on each of the coordinate axis proportion to the resultant magnitude. The balance condition for a convergent system of forces balance condition is if the resultant equal to 0, algebraic resultant, just magnitude the resultant is equal to 0. And it's not important to consider the rotating moment as forces if intersecting the one point the system is convergent. Then lines of action do not cause the rotation moment around the point of the intersect of the forces, so only the resultant force remains, no rotating moment. Three forces theorem we considered here. So if three forces act in the mechanical system and these three forces are in the balance, they are convergent, so they intersect in the definite one point in any place. In any place, not in the mechanical system, maybe outside of that, it's not important, but just in the one point they intersect. Thank you.